Hello, welcome to the final review. So this is just going through the first problem in problem set 10. So I want to just jump right in. In this first problem, we're going to consider a monopolist with the following production function. So it's going to be 3 times the square root of L plus the square root of K. And for now, we're going to assume input prices are W is equal to 2 and R is equal to 1. So for the first part A, we're going to try to find the cost function for the firm, given that it faces an avoidable fixed cost of $125,000. So to find the cost function, what we need to do is we need to first find the optimal inputs, like the optimal input choices, L of Q and K of Q. So given an output level Q, we need to find what the firm will optimally choose to minimize their cost. Furthermore, given that they have a fixed cost of $125,000, their total cost function is going to be this expression right here, where this is their cost of labor, this is their cost of capital, and then this is the fixed cost. So to answer this problem, what we need to do is we need to find the optimal choice of labor and capital for a given level of production. So to do this, for this problem, we need to use tangency. So we'll see how we do this in a second. But what we need to do when we're looking at tangency is we need to set the MRTS between L and K equal to the ratio of prices of those. So we need to set it to W over R. And this will characterize the optimal use of L and K given a certain Q. So here, just to remind you, this is the production function. It's 3 times the square root of L plus the square root of K. So the MRTS, the marginal rate of technical substitution, is defined as the derivative of the production function with respect to L divided by the derivative of the production function with respect to K. So I'm going to compute these derivatives here, and I will get that this is going to be 3 times the square, not the square root of L, 3 over 2 times L to the negative 1/2. So that's the derivative with respect to L. And the derivative with respect to K is going to be 1/2 times K to the negative 1/2. All right, so I can simplify this a little bit, and I will get 3 times K to the 1/2 divided by L to the 1/2. So this is what I get. Now, what I want to do is use the tangency condition. So I found the MRTS, and now I want to set the MRTS equal to W over R. So that's what I'm going to do here. So I'm going to set MRTS between L and K equal to W over R. So again, here we have W is equal to 2, R is equal to 1. So this means we have 3 times K to the 1/2 over L to the 1/2 is equal to 2 over 1. So this means if I multiply the L to the 1/2 over, I get 3 times K to the 1/2 is equal to 2 times L to the 1/2. Now finally, well, not finally, there's 2 more steps here. So I'm going to divide by 3, so I get K to the 1/2 is equal to 2/3 L to the 1/2. And now, finally, what I do is I can square both sides. And I get K is equal to, so I square this fraction. I get 4/9 times L. All right, so this is the tangency condition. This tells me based on what I use of L, it tells me how much I need to use of K. So I'm going to plug this in to the production function, and I'll set the production function equal to Q. So this says I want to produce output Q. This tells me how much L I need to use, given that I'm using K optimally. So that's what I'm doing here. So I'm going to set Q equal to F of L, and then we're going to use K is equal to 4/9 L in this equation. So 4/9 times L. So this holds only when Q is equal to 3 times the square root of L plus the square root of 4/9 times L. So I'm just going to plug this in for K. So I'm going to kind of rewrite this. Q is equal to 3 root L plus one thing I can do here. I note that the square root of 4/9 times L is equal to the square root of 4/9 times the square root of L. So this is going to be 2/3, because the square root of 4 is 2, the square root of 9 is 3, and then the square root of the fraction is the fraction of the square roots. So that's how I get this. I'm going to write this right here. So it's 2/3 root L. So I just did a bit of an aside to show you how I get from here to here. So this is Q. Q is 3 plus 2/3 times the square root of L. So what I did here is I just factored out the L from both of these, and I get it right here. So I'm going to rewrite this as an improper fraction. So this is going to be 9/3 plus 2/3 root L. In other words, Q is equal to 11/3 root L. Okay, so this means that root L is 3/11 times Q. And the last step, so I'm going to square both sides. So I'm going to get L is equal to 3/11 squared times Q squared. So L is equal to 9/121 Q squared. Okay. So this tells me my optimal level of L given that I want to produce Q. And yeah, so L of Q is equal to 9/121 Q squared. And then so K is 4/9 times L. This implies K of Q is just 4/9 times L of Q. So it's going to be 4/9 times 9/121 times Q squared. So this becomes 4/121 times Q squared. Okay, so I'm going to write these in their own box. All right, so that is the optimal choice of L and K. So we just need to plug this into the cost function and then find what that will be. So cost is 2 times L of Q plus 1 times 4 over 121 Q squared plus the fixed cost of 125,000. So again, this is W, this is L of Q, this is R, this is K of Q, and this is fixed cost. Okay, so all we do here, this is 18 over 121 Q squared plus 4 over 121 Q squared plus 125,000. This simplifies to 22 over 121 Q squared plus 125,000. Now, this may look like an odd number right here, but it actually simplifies in a nice way. So note, 22 is just 2 times 11, and 121 is just 11 squared. So this means I have basically 2 over 11 Q squared plus 125,000 as the cost function. All right, so this is the cost function of the firm when it is choosing inputs optimally. All right, so that's part A. Now for part B, we're going to suppose the monopolist faces demand of 3,000 minus 2p. We're going to find the optimal quantity and the corresponding price. Okay, so the monopolist is going to maximize profits. So the demand is 3,000 minus 2p. I'm just going to check that. Yeah, okay. So the monopolist maximizes profits. So here, the profits of the monopolist is just going to be price times quantity minus cost. So I'm going to write out what these will actually be, but I just want to give you some intuition for what we're going to be looking for here. One thing I'm going to do is I have this demand function where I see quantity as a function of price. But the monopolist is choosing Q, and then they see a price as a result of it. So what I'm going to do here is I'm going to find the inverse demand function. So this is price as function of Q, instead of Q as a function of P. So this means I'm going to have 2P is equal to 3,000 minus Q. What I'm doing is I'm just rearranging this to solve for P as a function of Q. That's all I'm doing when I say I'm finding the inverse. So given this, I get P is equal to 1,500 minus Q over 2. So this is the inverse demand function. Okay, so this is what the monopolist is going to consider. So the monopolist gets 1,500 minus Q over 2. This is the price they get based on the quantity that they produce. This is their quantity. And then we're going to subtract their cost. So So the cost we found up here is 2/11 Q squared minus 125,000. Okay, so the monopolist chooses Q star to maximize profits. So in other words, Q star sets marginal revenue equal to marginal cost. In other words, they want to set the derivative of profits with respect to Q equal to 0. So what I'm going to do is I'm going to take the derivative with respect to Q, and I'm going to set that equal to 0. So this is going to be 1,500 minus Q minus 4/11Q. So this is the derivative of profit with respect to quantity. So what I get here is I'm going to rearrange this and just solve for Q. So I get 1,500 is equal to Q plus 4/11Q. So 1,500 is equal to Q times 11/11 plus 4/11. In other words, 1,500 is equal to 15/11Q. This means that Q is 11/15 times 1,500. Now, 1,500 is just 15 times 100. So when we're dividing by 15, this just becomes 11 times 100, or 1,100. So the quantity produced by the monopolist is 1,100. Okay. So now we need to find the corresponding monopoly price. So the monopoly price is going to be determined by this inverse demand function. That's why it's a very useful thing for this problem, because given the quantity, we can determine what the price will be based on the demand function. So we'll have that P is 1,500 minus Q over 2. So this means that the monopoly price is 1,500 minus 1,100 over 2. 1,500 minus 550. So PM is 950. So price and quantity are 950. I'm going to write quantity first. Not that it really matters, just because that's the order we found them. All right, so that is the answer to this question. So we found the monopoly price and quantity. Now, we're going to find the profits for the monopolist and the margin that the monopolist charges. So here, we're going to find two things. So we're going to find profit. And secondly, we're going to find the margin, also known as the markup. Different terminologies to refer to the same thing. So what we're going to do is we're going to plug these quantities and prices into the profit function that we found up here. So I'm just going to copy this down here. And then we're going to replace, like we already computed this, so I don't need to compute it twice. Okay, so the profit of the monopolist is price times quantity minus the cost. So this is going to be 950 times 1100 minus 2 over 11 times 1100 squared minus 125,000. Now this is a big number. Basically what we're going to get is this is 1100 times 950 minus 2 11ths of 1100. So I just factor out one of these 11/100ths. And I'm just going to subtract away the fixed cost. And this is going to be a bit easier to solve. So this is 1100 times 950 minus 200 minus 125,000. So this is 1100 times 750 minus 125,000. This ends up being around 825. Not around 825, exactly 825,000 minus 125,000. You get a nice even 700,000. So this is giving us the profits of the monopolist. Kind of annoying computation-wise, but it's just some algebra, just some multiplying some numbers together. We just take the things that we computed in the previous problem, plug them into this profit function. Then we just kind of plug and chug and just compute all those things there. All right, now we want to find the markup or margins. So markups are given by the following formula. So it's going to be the price minus the marginal cost divided by the price. So here, just to recall, the cost is 2 over 11 q squared plus 125,000. So the marginal cost, it's a function of q, it's going to be 4 over 11 times q. Okay, and this means that the marginal cost at the monopolist quantity is 4/11ths times the quantity that the monopolist is producing, which is 1100. This will just be 400. You can check my math on that, but basically we have 1100 up here, there's 11 down here. That dividing the top of the bottom just gets you 100. Multiply it by 4, you get 400. Okay, so that gives us the marginal cost at the monopolist quantity. Here we have price is equal to, it was like 950. So we're going to use these pieces of information in this formula. So markup is going to be 950 minus the marginal cost, which is 400, divided by 950. So here we get that this is 550 divided by 950, which is approximately 58%. So this is a pretty high markup. Like they're charging, 58%. 58% of the cost of the product is just going directly to the monopolist. 42% of it is going to pay costs, but the rest of it is just pure profit. So that's how you compute markups or margins. All right, now we need to find the welfare loss that a profit maximum monopolist generates when compared with a monopolist with the same technology that maximizes welfare. So what we're going to do is, to do a comparison, we need to find what the welfare would be under this scenario where a monopolist is trying to maximize welfare. Then we'll compare that to what we found here. Okay, so in this context, if they want to maximize welfare, they would set price equal to marginal cost. This is essential for social welfare to be maximized. So we found in the previous problem, the marginal cost was 4/11 times Q. So when price is equal to marginal cost, we must have that price is equal to 4/11 times Q. So this is essentially what the price is going to be as a function of Q. In other words, we could write Q as a function of P. And this gives us a supply function. And what we're going to do is we're going to set the supply function equal to demand. So we need, I'm just going to write QS. QS is equal to QD. In other words, we need 11/4 times P equal to 3,000 minus 2P. And we're going to solve this for P. So we would get 11/4 P plus 2P is equal to 3,000. So 11/4P plus 8/4P is 3,000. And this means that we have 19/4 is equal to P is is equal to 3,000. And this gets us P is equal to 4 over 19 times 3,000. This is approximately equal to like 1,737. Yeah. So the idea is this is the price that the monopolist would set, given that they were setting price equal to marginal cost. Now what we need to do is we need to go back and find what the quantity is. So we're going to use this to solve for Q. So we know Q is equal to 11 over 4 times P. So Q is 11 over 4 times, I'm just going to write it in its unsimplified form, 4 over 19 times 3,000. So this is 11 over 19 times 3,000. This is kind of another annoying oh, sorry, I wrote the wrong thing here. My bad. That's embarrassing. Okay, P is 4/19 times 3,000. This is 632. Sorry about that. Okay. This is around 1737. The perils of looking at the wrong thing. Sorry about that. This is the price. This is the quantity. Okay. Now, what we're going to look at here is we're going to find total consumer surplus. So it's going to be consumer surplus plus producer surplus. So to compute consumer surplus, we're going to look at basically what we'll have is this is the price. Sorry. This is the consumer's demand function. As a function of P. And we're going to say the price is here. So the price is 632. They have an intercept of, it was 3,000, I believe. This is, more realistically, this is going to be like down here. So what we want to find, we're going to find this area right here. This is the consumer surplus. All right. We need to fill in some quantities here. So this horizontal distance right here is just going to be the amounts that's sold in equilibrium. So it's going to be 1737. It's sold at a price of 632. So we're going to look at the area of this shaded region right here. This shaded region has a height of 3,000 minus 632. So this is going to be, off the top of my head, it's going to be 2368, I think. Yeah, I'm going to have to check that one. But basically, yeah, that seems right. Yeah. Okay, so that's the vertical height of this. So the consumer surplus is the area of this triangle. So it's going to be the base times width divided by 2. So it's 1737 times 2368 divided by 2. This ends up being like, here I'm going to quickly type this in. So it's like 2 million and change. Okay. So that's consumer surplus under perfect competition. Now, one thing we'll note here is the producer surplus is going to be 0 because price will equal marginal cost. In other words, there's no profits for the firm. So the producer surplus is 0. Now, this is the welfare. This is the welfare when the monopolist is trying to maximize welfare. What we found here is we found that Q was 1737, which is much higher than what we found in the previous part of the problem. In the previous part, we found that the monopolist was only producing 1,100 and the price was 950. Here we see the price is much lower, the quantity is higher. So people are better off when in this alternative scenario. So what we want to do is we want to compare these outcomes. So I'm going to just go off to the side here and find the welfare of the first scenario. So we had the profit of the monopolist was 700,000. So we found that right there. So this is producer surplus. And then what we're going to do is we're going to compute consumer surplus. So in a similar way, we're going to look at the consumer's demand function. They're paying a price of, sorry, I dropped my pencil. Price of $9.10, or $9.50. And the quantity was 1,100. So what we're going to do is we're going to find the area of this shaded region. So this is the consumer surplus under monopoly. Under the monopoly where they're not trying to maximize welfare, I should say. And there's the intercept of 3,000. So we're going to find this vertical distance and then the width of this base. So this base is 1,100 because this is the quantity. I should label my axes here, sorry. And then the height of this part right here is going to be 3,000 minus 950. So this is going to be 2,050. So the consumer surplus here is going to be 2,050 times 1,100 divided by 2. So this is going to be 1,133,000. Okay. Again, producer surplus is 700,000. So we end up with total surplus is equal to 1,833,000. So the change in welfare, or the difference in welfare, is going to be 1,833,000 minus the one where they're trying to maximize welfare. All right, so according to my calculations, if I haven't done anything wrong, we'd see the decrease in welfare when the monopolist is pricing to maximize their own profits versus when they're trying to maximize societal welfare. So this shows that monopolies are inefficient and that their interests are not aligned with the interests of society. So this is kind of just showing you that idea. I believe that's all of it. No, okay, one more. Never done. Okay, so competitive market, free entry, many firms with the same technology used by the monopolist, but okay. So here what we're going to do, we're going to use the minimum average avoidable cost. This will characterize the price at which firms are willing to produce. So the avoidable cost. So here, C of Q, again, is 2 over 11 Q squared plus 125,000. The avoidable cost is just the same thing. Average avoidable cost is equal to AC of Q divided by Q. So it's going to be 2 over 11 Q plus 125,000 divided by Q. So we want to find the minimum So we're going to find the minimum of the average avoidable cost. This means we'll find the efficient scale by setting the derivative of average avoidable cost equal to 0. And then using that, we'll plug that back in to find the minimum average avoidable cost. So the derivative of average avoidable cost with respect to Q is equal to 2 over 11 minus 125,000 over Q squared. Set this equal to 0 because we want to find a minimum. So this means we have 2 over 11 is equal to 125,000 divided by Q squared. In other words, we get that Q squared is 125,000 times 11 divided by 2. And this means that Q is the square root of 11 over 2 times 125,000. And 125,000 is just going to be 250 squared. That's a little fun fact. So Q is equal to 250 times the square root of 11 over 2. Unfortunately, 11 over 2 is not a perfect square, so we can't do anything there, but we end up with this function for this expression for Q. So this is the efficient scale. Now the AAC min, it's going to write an E to indicate it's the efficient scale. So it's the AAC at QE. So this is 2 over 11 times 250 root 11 over 2 plus 125,000 divided by 250 root 11 over 2. Now here I can get some cancellation. This is 250 times root 2 over 11 plus, this is like, I don't know how that simplifies. It's basically like 301. Huh. I wonder if that was deliberate. I guess I'll never know, but that's funny. What a coincidence. Okay, so this is the AAC min. And when we have free entry, so firms will enter until price is equal to average avoidable cost min. So this means equilibrium price is going to be 301 approximately. And then the quantity that firms will produce, well, we determine this by the quantity rule. So we need price equal to marginal cost, given we have competitive firms. So this means price is equal to, here the marginal cost is 4 over 11 Q. So this means 301 is 4 over 11 times Q. Oh, sorry, this is wrong. Sorry, I got lost for a second there. This is price. We can just directly plug this into inverse demand. Or plug into demand. Okay, forget what I said. I was being dumb. So we're going to plug this into the demand function to get the equilibrium quantity. So Q star is 3,000 minus 2 times 301. So this is going to be, well, what it's going to be. So it's going to be like roughly 2,400, give or take, maybe 2,398. something like that. I don't know. Anyway, thank you for watching. I hope that this was informative. I know it was kind of a long problem. It took me 5 pages. But the idea is this is just a lot of steps kind of put together. So for the first part, we do a little cost minimization, find the cost function. Then for part B, we solve a monopolist problem, find the optimal quantity they produce, and the corresponding price. And we use the cost function we find in the first part. So again, it's important to find this. Then we find the profits of the monopolist. We find the margin or the markup that the monopolist charges, and we see that it's pretty high. Then, because the monopolist is getting a positive profit, they're not pricing efficiently, they're not pricing to maximize social welfare. And they're pricing efficiently for them, but they're not pricing to maximize consumer surplus and producer surplus. They're just maximizing their own profit. So here there's going to be a welfare loss when we have a monopolist. And generally we don't like monopolies, and this is why. So we're going to compare it to the situation where the monopolist is charging a price equal to marginal cost. And we see when the monopolist is trying to maximize welfare, well, welfare is going to be higher. And then finally, in the last problem, we see what happens when there's free entry of firms and there is competition between firms. And we see that there's going to be a different outcome in this market when we have free entry of firms. All right, thanks for watching. I just wanted to recap and summarize.